This video is going to be about systems and processes as they apply to thermodynamics. A system is the object that we're interested in, and everything outside that system is the surroundings. In thermodynamics, when we have a hot system and cold surroundings, heat, Q, flows from the hot system into the cold surroundings. If we flip it, so now our system is colder than the hot surroundings, heat will flow from the surroundings into the system. There are three types of systems you need to know. An open system is a system where mass can enter and leave. A closed system is one where mass cannot enter or leave. However, in an open and a closed system, energy can be transferred from the system to the surroundings and the surroundings to the system. An isolated system is a system where energy cannot enter or leave. You also need to understand thermodynamic processes, and we'll illustrate those on something called a pressure-volume diagram. We'll plot pressure in pascals on the y-axis and volume in meters cubed on the x-axis. These diagrams are very useful in illustrating thermodynamic processes, and you'll see later on that we can also use them to find the work done and the work done on a gas. The first process we're going to talk about is an isothermal process. An isothermal process is where the temperature of the system stays constant. An isothermal process makes a curve on a pressure-volume diagram like this. I'm showing an expansion here because the volume is increasing. Next process we'll talk about is an isobaric process. An isobaric process is where the pressure stays constant. An isobaric process would look like this blue line on my pressure-volume diagram. Notice how the pressure doesn't change while the volume increases. So this would also be an expansion of the gas. Next process we'll talk about is isovolumetric. An isovolumetric process is where the volume stays constant. This green vertical line on my pressure-volume diagram is what an isovolumetric process would look like. Because the volume isn't changing, this is neither an expansion nor a compression of the gas. The last process you'll learn about is an adiabatic process. An adiabatic process is where no heat enters or leaves the system. On the pressure-volume diagram, an adiabatic line would look similar to the isothermal line, but it would have a much steeper slope. This is an adiabatic expansion of my gas. Orange with a steep slope, and in black we see that the isothermal expansion has a less steep slope.